Hi, my name is Abdulmalik Umar, and this is my demonstration for COM 4601 Assignment 1. I've built a search engine that crawls two websites, computes PageRank, and allows users to search using the TF-IDF scoring with cosine similarity. Okay, so first I'm going to demonstrate the Fruit A dataset. This is a set of 100 pages crawled from the HTML given the example on the assignments. I'll pick a fruit word like apple, for instance, here, and look for the first 10 results that come up. You can see that the results are ranked based on their TF IDF scores, showing the URL, the title, score, and page rank for each result. Now let me enable page rank boost for the same search results. And you notice that the rankings have changed because the scores are now multiplied by each page's page rank value. I'll click view details so you can see. Okay, so this is the view details page that shows the title of the page, its URL, its page rank, which is being used, the number of incoming links, number of outgoing links, and the top 20 most frequent words. I limited it to 20 so it doesn't become a very long list of pages that have like so many words. Okay, so next I'll try and demonstrate using my personal data set, which is this website here, Box to Scrape. It's basically a website made for scraping. I'll search for a word like mystery. Sorry. And just search. And these are the results for mystery, limiting it to 10 results. And you would see how this page changes when I turn on the page rank boost system. And you see how the results change when I use the page rank boost system. So you can see it's different pages that have come up here on the result page. And I can view a page details and it should have the same result. This is the title of the page, its URL, page rank, number of incoming links to that page, number of outgoing links from that page, and top 20 word frequencies on that page. Okay. Okay, so my crawler is defined in Crawler.js. As you can see, the two data sets shown there. This is where I define the data sets used in the websites. It shows their seed URLs, domains, and page caps. Okay, so for each page I visited, I extract the title using this title.text.trim and the paragraph using paragraph.text.trim. And then that text is then lowercase and stripped of all of non-alphanumeric characters and split into individual words. After that, I extract all the anchor references and resolve them to absolute URLs and the URL constructor filtering to only keep the links within the same domain. That's what I do in this area. So I'm only trying to keep the links within the same domain. So the crowd doesn't go further than the area I want it to go. Also, as each page is crawled, I also update the incoming links of every page it links to. So by the end of the crawl, every page document has both incoming and outgoing links populated. That's going to be useful for the PageRank system I'm going to show in the next segment. As for the RESTful design of my server, it follows the REST principles in various ways. Each resource has a clear URL, as you can see here, /fruits_a/personal/page for individual like page details. I use HTTP GET requests for all data retrieval, which makes it stateless. That means each request is going to contain all the information needed to process it, including the query, the boost flag, and limits. Like boost flag meaning is it going to be PageRank boosted or not? The limit determines how many results should be posted on the result page. The responses are always JSON, making it easy for the API to be uniform and easily consumable by the clients. The server does not maintain any session state between requests. So in terms of scalability, I would say I can increase the rate at which I crawl the web page because currently I'm being nice to the server to not overload it and get denied access. However, I can increase this max connections to make me crawl more than one page at a time. And also here in my data sets area, I cap the pages to be 10,000, 2,500. I can increase that to make it, more scalable based on the project I'm trying to work on, basically. Okay, so how is the content score generated? The TF is calculated in this compute TF function here. The TF is computed as word count divided by total words in the document, as you can see. And for the IDF, I use log base 2 of n divided by 1 plus the document frequency. Over here, you can see me using mathmax bounded at 0 to prevent negative values. And over here, the final TF IDF scores for each word is log base 2 of 1 plus TF multiplied by the IDF over here. That's what's done here. And for the cosine similarity, I computed that between the query vector and each document vector by taking the dot products divided by the product of their magnitudes. That's done in this line here. And for the PageRank calculation, I built an n by n matrix where each entry is the probability of moving from one page to another. That's the dangling node, and this is where the dampening factor occurs. And this is the power iteration loop, which, it starts with a uniform distribution rule vector, and then I repeatedly multiply it by the transition matrix. I usually stop when the distance between iterations is less than 0.001, and then it updates everything and saves it back to MongoDB. Okay, so how do I maintain page selection policy for my personal sites? I think I already explained this earlier, so basically here my selection policy is domain based and it only follows links that stay within like books2script.com, the said domain. Okay, so here's why I use a breadth first traversal, following all the links on each page before going any deeper. And then I limit it to 2,500 for the personal sites to keep the crawler manageable. Why did I choose this site I chose? I chose Book2Script because its main purpose is built for scripting practice and it has over 500 pages in HTML. A challenge was that a lot of the content is in structured elements rather than p tags. Since I only extract the paragraph text, pages with difficult like p text produce fewer meaningful words. And then I'm just relying on the book description paragraphs that are available, which provided enough content for me to scrape the websites. A critique I have for myself is, the search engine works well for the most part for data sets that it's built for. However, the limitations are shown in the way the pages are loaded. Loading all the pages into memory on every query is a very big scalability problem. And only extracting paragraph text sometimes it misses content in the headings and lists. And finally, storing a full n by n matrix in memory will not be like sensible to do for like web scale datasets. it would rather use like a more intricate representation for that. And that concludes my demonstration. The server is deployed on OpenStack and registered. Thank you very much.